This is the example that we did in class today. So I'm going to graph the points that they give me. Okay. I graph the points. So here I get A is 11, 3. So 1, 2. Oh, I don't have enough space.
Download YouTube? Okay.
Sorry, I had to get a new axis. The other one was did not look good. Okay, so now let's plot our points. We have 11, 3, 1, 2, 3. Okay, so this one is A. B is 3, negative 11. Negative 11. Okay, that's B. C is negative 13.
Bye.
5.
When are we finishing
C.
that? Maybe tomorrow?
And then,
Can I take tomorrow that too?
and
Yeah?
then D is 5. D is 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 9. Okay. So now I connect my points. Get this here, this here, this here, and this here. Okay. So now I have my quadrilateral. It says the corners of the first fence are located at points A, B, C, D. The media must stay within the fence area. So the media has to stay in here. Connect the points in alphabetical order, then join point D to A. Okay, we did that. So it says find and label the midpoints of each segment of quadrilateral ABCD. Okay, so we need to find the midpoint of AB, which is going to be point Q. So we write point Q, AB, and we want us to use the midpoint formula. So let's put the formula up here. Okay, so that is our midpoint formula. So using that formula up there, we're going to find the midpoint of AB. So we have X midpoint is 11 plus 3 over 2 equals 7. And then the Y midpoint is negative 11 plus 3 over 2 gives me negative 4. Okay? So then I need to find the midpoint R, which is the midpoint of the line BC. So I get X midpoint equals 3 minus 13 over 2. Oops. Which gives me negative 5. And then I need to find the Y midpoint, which is negative 11 minus 9 over 2, which gives me negative 10. I need to find midpoint S, which is the midpoint of line CD, and I get X midpoint is negative 13 minus 5 over 2, gives me negative 9. The Y midpoint is negative 9 plus 9 over 2, which gives me 0. Okay, now I need to find midpoint T, which is the middle of line DA. So I'm looking for X midpoint is negative 5 plus 11 over 2, which gives me 3. The Y midpoint is 9 plus 3 over 2 gives me 6. Okay, so now I have found 4 points, and these are the midpoints that I'm going to put onto the figure. So let's put them into the figure right now. I have midpoint Q, which is 7, negative 4. I'm going to put that in the figure now. I have 7 over 1, 2, 3, 4, and that is the midpoint of AB. So this here is Q. Then I have midpoint R, which is negative 5, negative 10. Okay. And that one goes here, 5, down to negative 10. And we call this one R. Now I have midpoint S. Midpoint S is negative 9, 0. Okay. I put that in the figure. I get negative 9, 0. This is S. And then I have midpoint T. Oh, hold on. Let's put this over here. And then I have midpoint T, which is 3, 6. So you see how the midpoint formula, you need to get an x value and you need to get a y value, and then it makes a coordinate. So when you guys write x midpoint formula equals x endpoint plus x endpoint over 2, and then you don't write the second part, I worry that you don't know what you're actually finding here. So I need you to make sure that you do an x value and a y value when you find the midpoint of something, right? Okay, good. So now we are putting the midpoint of dA, which is t, on here. We have 3 over 6 up, and this here is t. So the question says, after I find those midpoints, connect the 4 midpoints in alphabetical order, okay? And it will create a new quadrilateral, QRST. Okay. The quadrilateral represents the fence surrounding the archaeological dig site. Okay. We need to find out what kind of quadrilateral is ABCD. What kind of quadrilateral is it? Well, first, let's see if opposite sides are parallel, because then we can move forward from there. So let's see if ST is parallel to RQ. How do we determine whether things are parallel or not? We do slope formula. So I hope you got this work down here because I'm going to erase it so I have some space. Okay. I need to erase it. So I need to prove ST is parallel to RQ. This line is parallel to this line. So let's use slope. First we write down our property. 1, opposite sides are parallel. Okay. Oh, first we need to determine whether ABCD is a quadrilateral. Okay, so let's do that part first. So opposite sides are parallel. Let's look at ABCD. Let's try to prove that CD is parallel to AB. Let's see what we get here. Or no, let's do DA parallel to CB, okay? Just to show that it doesn't matter which one you pick. So here I want to prove opposite sides are parallel. I do the slope of DA equals 3 minus 9 over 11 plus 5. This gives me negative 6 over 16. I reduce, I get negative 3 over 8. Now the slope of CB, let's find the slope of CB. The slope of CB, I get negative 11 plus 9 over 3 plus 13. This gives me negative 2 over 16. I reduce, I get negative 1 over 8. These slopes are not the same, therefore opposite sides are not parallel, therefore A, B, C, D is not a parallelogram and just a quadrilateral. So I write A, B, C, D is just a quadrilateral. And I'm going to write that again up here so the person grading my paper knows exactly what I am talking about. Okay, so now I need to find what kind of quadrilateral a QRST is. So this one down here. So now we're going to find if ST is parallel to RQ. So let's use slope to do that. So now I write again, opposite sides are parallel because I want to show that I know what property I am using and trying to prove. I have the slope of TS is 6 over 12, which reduces to 1/2. And then I found the slope of QR, which is -10 plus 4 over -5 minus 7 equals -6 over -12 equals +1/2. They have the same slope. ST is parallel to RQ, so we say yes, parallel. And now I need to prove that the slope of TQ is parallel to the slope of SR. So the slope of TQ, I get -10 over 4, which gives me -5 over 2. Then the slope of SR, I get 0 plus 10 over -9 plus 5, gives me 10 over -4, gives me -5 over 2. So this slope here equals this slope here, so we say yes, they are parallel. So this quadrilateral here is a parallelogram. So quadrilateral QRST is a parallelogram because opposite sides are parallel. And in class, we later went on to prove that this holds true for any quadrilateral. You could have the ugliest quadrilateral in the whole world. You could have a quadrilateral that looks like this. You connect the midpoints of this quadrilateral here, and you will always get a parallelogram inside.